Welcome. Today, we're pulling back the curtain on a process that is absolutely critical to the energy world, but almost never gets the spotlight. It's a real unsung hero, so let's get into it.
Okay, so let me ask you something. Picture one of those massive, sprawling, billion-dollar oil facilities. What do you think is its single biggest threat? Are you thinking about a major mechanical breakdown, a huge storm, maybe? Something really dramatic, right?
Well, the real answer is probably not what you'd expect. One of the most relentless and damaging threats is actually the grease and grime. Yeah, I know, it sounds simple, but this stuff is a quiet enemy, and its impact is absolutely massive.
So, to really get why this is such a huge deal, we've got to dig into what we're calling the invisible grime problem. Where does all this gunk even come from, and what kind of trouble does it actually cause?
The real challenge here is that this stuff is everywhere. It's not like it's coming from just one leaky pipe. You've got lubricating oils from all the moving parts, process hydrocarbons, hydraulic fluids, heck, even the protective coatings and just day-to-day maintenance work add to the buildup. It's a constant battle from all sides. And let's be clear, this is so much more than just a little dirt. This layer of grease and oil physically gets in the way of vital work. It can hide cracks during an inspection, ruin a perfect weld, and just generally grind the whole operation's efficiency to a halt.
So, how in the world do you fight back against an enemy like this? Well, the industry has basically developed a specialized toolkit for this exact purpose. So, let's crack it open and see what we're working with. From a bird's eye view, you've really got two main chemical strategies. First, there's alkaline cleaning. This method basically performs a little magic trick, turning all those oils into simple soap. Then you've got solvent cleaning. These are the heavy hitters you call in to dissolve the really, really tough gunk.
Let's zero in on that first one for a second. The key scientific process is called saponification. And if that sounds kind of familiar, it should. It's literally the same chemical reaction we use to make soap. Think about it. When you wash a greasy pan, your dish soap breaks down the fat. Alkaline cleaners are doing the exact same thing, just on a massive industrial scale. And this method is super popular for a couple of good reasons. It works really well, and it's pretty cost-effective. On top of that, modern versions get a boost from things called surfactants, which are additives that make them even better at lifting that grime off surfaces and washing it all away.
But what happens when you're up against something truly nasty? The heavy oils, the thick waxes, or things like asphaltenes that pretty much just laugh at water-based cleaners. Well, that's when you have to bring out the big guns, the solvent degreasers. They're designed to dissolve the stuff that nothing else can touch.
And the world of solvents has really evolved. The old school stuff, the chlorinated solvents, they worked, but they were pretty rough on the environment. So now the whole industry is shifting towards much safer, greener options, like bio-based solvents or even using high-pressure carbon dioxide. It's pretty cool, actually. Now, as you can imagine, working with these kinds of powerful chemicals is no simple thing. And that brings us to a really important point. The stakes here are incredibly high, which means the standards have to be even higher. And we need to be crystal clear about what's at risk. These chemicals, many of them are flammable. They can be toxic to the people working with them, and if they aren't handled right, they can be a real hazard to the environment. There is just zero margin for error. And that's exactly why every single part of this process is governed by strict, strict rules. We're talking about detailed protocols for how you handle them, how you contain them, how you get rid of the waste, and of course, all the protective gear the crew needs to wear. When you're doing this work, safety is everything. Because it's so complex and so risky, this is absolutely not a job for just anyone. This is when you call in the specialists, the experts who live and breathe this stuff, who know the science and the safety protocols like the back of their hand. See, the pros follow a very specific game plan. It always starts with a deep dive, assessing exactly what kind of contamination they're up against. That tells them which method to choose. Then, after they apply the treatment, they don't just pack up and leave. They stick around to verify that the job is done right and that everything is safe. And that right there really tells you everything. Professional degreasing is a science. It is all about crafting a tailored solution for a very specific problem. You can't just grab any old cleaner off the shelf. It takes real expertise to match the right tool to the right job. So when you think about it, industrial degreasing really is an unsung hero.
It's this complex, high-stakes job happening completely behind the scenes just to keep our entire energy infrastructure safe and running smoothly. It really makes you wonder, doesn't it? What other invisible jobs are out there quietly keeping our world turning?